So we left off the last section by having you assess the drawing that's up on the monitor section here. We gave you the starting point, and we're also showing the directions that we'd like you to go. So there would be a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points total, where the first and last point are the same. So what I've done is kind of set up a matrix here. So we'll go with point number 1. And then point number 2, 3, 4, 5, 6, 7, 8, 9, 10, and then point number 1 is also point 11. I have a column here for the x values. I have a column here for the y values. So let's start by saying, okay, this is point number 1 right here. This correct answer would be a value of x16 and y9. So for point number 1, it's x16.0 and y9.0. Now I'm starting to look at putting in dots for decimal points and 0. At the very least, you should consider making it a habit to use decimal points, because as you're programming out on the machine, most machine tools, the control will require a decimal point. Otherwise, it will interpret the number 16, for example, as 0.0016 instead of 16. So now we'll start adding decimal points for clarity, and stay with that convention as we now move forward. Point number 2 is in the same x value as point number 1, so that's number 16, but it has a y value of 2.0. So point number 2 is at x16 and y 2.0. And that brings us to the beginning here. Now our move goes down here, and that is x14, y minus 1. All we're doing is saying point to point to point to point, and then the cutter will, in this example, follow a straight line path. So even though this is at an angle, it's just looking to get to the endpoints. And so it goes to x14, y minus 1 would be the next correct answer. So that's x's value of 14. And now we're below the y-axis. So anything down here is the x plus y minus quadrant. So now the next point takes us to here, and that puts us at x8, y minus 1. And now we're going to move up to here. So that stays at x8, but goes back up to the y plus side of 4 inches, 4 units. So this stays at x8 and y 4.0. So you'll see, if you haven't already noticed, that we're expressing every point as an x and y coordinate pair from this origin point. Next move, we've been up here, so now we're going to move to this point, which is going to be x 4.0 and y 4.0. And now we're going to move down. We stay at x positive. Now we go to y minus 1.0. And now the next move puts us here. Now notice we're going to the left of the x-axis origin. So that, of course, becomes an x minus value, and it's x minus 1 from our 0. So x minus 1 and y minus 1. Moving up to here, we're at x minus 1 still, but back up into the y positive side. So that becomes y positive 7. And now we're going to move to here, and that is x7, y9. And then our beginning point is the same as our end point. So we always begin and end, if we want this profile to be closed, We could say down here, we could say 11, and then that's y minus 9, or y plus 9.0. So I hope that's what you found. And now, a couple of things to look at. We talked about milling as a process, and to make your first NC program, using this data is really as simple as first doing exactly what we've done, just identifying the locations that we want our cutter to move in terms of x and y coordinate pairs. And if we want to make this an NC program, it's very simple. All we need to do is use these numbers, and we won't put this in our NC program, but to make it able to be run, you will just create a file. Any sort of text editor will do. And then all you need to do to make this a valid NC program is put an access address in front of each of these values. Well, there's many things missing still, but the point being that to make this a valid NC program simply requires an axis address if you want the axis to move, and then a value that you want it to move to. So we now have a valid NC program. It's just that simple. Typing this into an NC control will give you valid movement, but you have to qualify it. There's many things that come into play. For example, we need to tell the NC control what kind of units these are. Are they inches or are they millimeters? So the first thing we're going to talk about are what we call preparatory functions. NC programs have always either axis movement or some type of preparatory or auxiliary type work that they do. For instance, if you're not moving an axis, you might be turning on a spindle. If you're turning on a spindle to prepare for cutting metal, you might be turning on some coolant. So all an NC program really is a way of doing these things. Turn on spindle, specify an RPM, turn on coolant, bring your cutter down, and let it start making a part program or part profile based on the coordinates you provided. Now there's other kinds of functions that we use on the NC control. I'm just going to show you one right now. It's something called a G20. Preparatory functions have the letter G and then some kind of number. And when you create a file that has a G20 in it, we're saying, hey, everything that you see in terms of a number is an inch value. If we told it G21, for example, it would come back and say, oh, those are metric. But if it's inches, we say G20. Next thing we got to kind of tell the control is that if you notice these coordinate pairs, all come from the 0 point on the origin of our Cartesian coordinate system, right? So each of these is an absolute value from this 0. So this point, its absolute values are 16 inches away and 9 inches up and so on. That's what this G20 is used, or G90 is used for. You see I have something here called a G91, but I've asked you to ignore that. And just ignore it for now because it really is nothing that we need to worry about at this particular point. But do consider a G90 right here. What we would do is we would tell our control that, hey, all the coordinates that follow are absolute values from an origin point. So we tell the control G90 And then we tell it G20, which now says, okay, all of these values are actually inches. So the machine will make a 14-inch move, which might be something this wide, as opposed to a 14-millimeter move, which would be something much, much smaller than an inch. Maybe roughly half an inch. And what we are doing is now introducing you to other functions within the CNC control. So remember, CNC controls are axis movement, in which case if you wanted to make axis movement, you simply tell it where you want to go in terms of a coordinate and which axis you want to move. So here you see we're making a bunch of X and Y moves. So what the controller is literally going to do, it's going to follow the order that you've keyed in these commands, point 1, point 2, exactly as you've typed them in. Now we're not making allowance for a cutter diameter. As you recall, when we were talking about machining processes, that cutters and mills have diameter. Now, what we would be machining, this is just for your information right now, if this is our coordinate system, here's our origin, and our part profile looks like this. Okay, that's our part profile. So what we're saying is all these points, point 1, point 2, point 3, and so on, are absolute values based on that origin point, and that they are also inch units. So now the machine basically will move the center of the Z right over X16 and Y9. So you see, if this is our finished part, we're actually programming the center of the end mill. Which you need to know, because eventually we're going to have to take into account a diameter of cutting tool. But at this point in our discussion, it's not that important to see how to do that. Conceptually, what you should be noting is we have axis movement, we have values of axes, we have preparatory functions, and these numbers are determined by the CNC control. The CNC control knows every time it sees a G word followed by the number 20, no space by the way, it knows that we're talking about inches as our units. Anytime it sees a G followed by the number 90, it knows that we are talking absolute coordinates from an origin point. Know that these numbers always are the center of your spindle and not the edge of a tool. So in reality, what would our finished part look like? Well, we would have the cutter will have gone around, so the part will actually be smaller by the diameter of the cutter. And this will come to light a little bit later. So we've not only now introduced you to the Cartesian coordinate method or thinking, which is the basis of all NC programs, we've also introduced you to the concept that we now have units and we have ways that we can express numbers differently. Are they absolute numbers from an origin point? Yes. If so, conceptually we now use what's called a preparatory function to advise the control that that's what we're going to do. Now, the next thing we want to think about is that if you remember in my demonstration on the machine, the axes can move two ways. They can move in what we call rapid travel. In other words, they're just going to go flat out as fast as they can travel from point A to point B. We use the rapid travel to minimize time it takes to move the machine in space. So your machine, you either have the tool in material doing cutting work, or we have the tool positioning itself, getting ready to cut, which there's no material, engaging the work tool, in which case we can move it around as fast as we can because the tool will be in the air, it won't be in material. Call that rapid movement. Whenever we have a tool in material, if you remember from our process discussion, there are logical feeds that the tool must travel. If you've ever tried drilling a hole with a simple hand drill, for example, if you had a very large diameter drill in your electric drill and you tried to drill a piece of metal, chances are you probably didn't have enough power in your arm to drill a piece of metal with a very large drill. And then if you took that same large drill and tried to drill a piece of wood, the drill would start working, but you'd actually have to slow it down. Because if you were going too fast for that drill, it would not be able to effectively engage the material. So that's what we consider as a cutting feed rate. So you not only slow down the RPM, but you slow down how fast you're advancing the tool into the material. That's what we call the feed rate, right? Take that big drill into a piece of wood, you're going to do it by hand, you're going to feed it slowly. And as you feed it slowly, you'll see it's cutting more effectively. So by slowing it down, slowing down the speed of the spindle or the tool, slowing down the pressure that you're applying, all comes into play and all has to be considered. So on the NC machine, there's two kinds of motion that you can consider. Rapid travel motion, which think of rapid traveling as traveling them on the axes where the tool is not in material, and then traveling with the tool in the material at a feed rate. If you look up here now, I have a little example of the two kinds of feed rates that we use, or expressing how we want to move the axes. So we have what's called interpolation. In other words, we want the tool, when we're going from this point to this point, from point 1 to point 2, we're actually in material. So what we want to do is have the tool advance at a predetermined speed that we choose. And we express that speed in terms of a feed rate per minute. So, as opposed to if we wanted to move this tool around this profile at a rapid, very quick feed rate, being that we're up in the air and not cutting material. So another preparatory function that we'll introduce you to is called a G01. G01 says that we want this to move at a predetermined interpolated feed rate. We want you to move the same rate and the same distance for each axis, and we want it to be slow and easy as opposed to very rapid or very quick. This then becomes what we call a linear interpolation move, meaning the axes are moving in straight lines, and I'll just put a G01 in front of each line to remind us that we're telling the control to move at a slower, predetermined feed rate. We don't want it to rush at a rapid travel through there. So, this is the next preparatory function I want you to be aware of, and it's what we call linear interpolation. So it is telling the control, move at a linear amount, in other words, a straight line or a line at an angle, but it is straight. There's no radius or there's no circular component to this movement. So it's straight, what we call linear interpolation, and that means both axes will move at equal amounts and give us a nice profile at a predetermined feed rate through the part. Alternately, if we were to change one of these lines to what we call G00, a G00 now says move at the fastest possible rate that your axes can take you. So that would mean that starting here, we're at this point, and then we say G00, X16, Y2, which means we want to move down to point number 2 as fast as the machine can possibly take us. And that would not be a good thing because we're actually in material. So when would it be appropriate to use a rapid or a G00? Well, let's put it this way. I'll change this back to G01. But let's now assume that we have a part sitting on our table, on our machine table. So I'll kind of draw that right here in a smaller way. Let's say this is our machine table, and our part is sitting right here on the machine table. Okay? The machine is located somewhere before it reads this first line. And let's just say it's sitting over the top edge of the table. It's just the machine is here. So as we go and do this program, it's going to say G01, X16, Y9. That means movement will actually be taking our tool and moving it to the first cutting position. This move, depending on where the tool is sitting before it starts running your program, would be at a feed rate. So if this move were 20 inches and your feed rate was set to move at 5 inches a minute, how long would it take you to get from point A to point B here? It would take you 4 minutes, right? Because if you're going at 5 inches per minute times 4 minutes, you have 20 inches that you've just moved. Simply to get the tool over the first cutting position. So, my question to you was, when is it appropriate to use rapid feed rate? Your answer would be when we're positioning the tool to get it ready for cutting. So by me changing this first line here to a G00, it's going to say, hey, rapid travel to that position, and then start doing a feed rate around the rest of the profile. Okay? So now, this is still considered preparatory function. These are considered axes addresses, so we've introduced you to a couple of new ones. We now have looked at G, so that would be G90. We looked at G20, and now we are looking at G00 and a G01. 4 different preparatory functions. Now, I'm just going to warn you ahead of time that the Mitsubishi control on the end mill, on the milling machine that we're looking at, has about 100 or more different kinds of G-codes. We'll review what many of those are. But we have preparatory functions, or G-codes, that do a lot of different things. There's G-codes that say move at rapid, move at feed rate. There's also G-codes we're going to look at in just a minute that tell it to move in a circle. So if you're cutting a circular fillet or something, we have a special G-code for that. We have G-codes that tell it whether to drill a hole or tap a hole. We have G-codes that tell it inch or metric. We have G-codes that tell it how to behave when it's drilling the hole, So there's many different kinds of G-codes that we have. So I've introduced you to 4 of them, and then I've also introduced you to axis movement. We're just telling the machine where to move the X and Y axes in terms of inches, which the G20. So we're saying from wherever that coordinate origin is, move 16 inches in X and 9 inches in Y, then move to 16 inches in X and 2 inches in Y, and so on. So now working to our next example, we have these shapes right here. Let's assume these are shapes that we want to do feed rates on, but then from this shape to this shape, we want to do rapid movements to position. So here we have a shape that's a triangle, and then we might want to take and go over to here and do a feed rate move on that shape, and then we might want to take a rapid move and go to here. Why don't you write me very quickly a part program to do that? And in a few minutes, when you're done, we'll review it for you.